Okay, 2.3, we were given this series 10 plus 5, and we had to show it was convergent. We showed it was convergent by showing it had a constant ratio of a half, and showing that half is less than 1 greater than -1, which satisfies our convergence property. Okay, then in the next question, it says determine the sum to infinity minus Sn, which is the sum to the nth term, in the form a times b to the power n, where Sn is the sum of the first n terms of the sequence. So the first thing I'm going to do is I'm going to write out sum of infinity and sum of n, which you should know from theory. So sum of infinity we know is a1 minus r. This is for a convergent geometric series, where a is our first term, of course. So in this case, it's 10 over 1 minus a half. So that becomes 10 over 1 half, which is the same as saying 10 times 2, which is equal to 20. Cool, so that's sorted. So that's the sum to infinity sorted. Now let's do sum to n. So the nth term is equal to, this is also from theory, a1 minus rn over 1 minus r. I believe you do get a formula sheet in these exams. I can't remember, but that's how it worked when I was there. So hopefully if you get confused or you're a bit stressed, just make sure that you write these equations down correctly. And if you don't, obviously remember them well. So then a is 10, then 1 minus half to the n over 1 minus r is also 1 minus a half, so it's exactly the same. So that's a half, and then that simplifies to 20, 1 minus a half n. Cool. So now I can say sum of infinity minus sum of n is equal to 20 minus 20, 1 minus a half n. Okay, so that's just taking this and subtracting it from 20, which is exactly this. But notice how they want it as a product of b to the power n times a, which this is definitely not part of. So let's do the only thing we can do, and that's multiply out this 20, and then hopefully it will simplify from there. So we can say this is equal to 20 minus 20 times 1, so that's 20, and then minus 20 times, if you imagine there's a little 1 here, then we get plus 20 times a half to the n. And then, of course, these 20s cancel very nicely. And we've got this now as 20 times a half to the n. And that satisfies the format in which they wanted us to get the expression. So there we are.